10.2 today. We're going to add on some more rules to my blue sheet, so I'm hoping those are all in front of you. We're going to add and subtract radicals today, which we have not done yet. So, in order to add or subtract radical expressions, the one rule that we must follow is that they must have the exact same radicand. Remember that word radicand, part of our vocab. Radicand means that the thing on the inside of the radical has to be the exact same in order for us to add or subtract them. This process is exactly like what we do with variables, called combining like terms. Oh, there it goes. So I want us to think about if I were to combine two things with variables, like I'm going to write up at the top here. If I said 2x minus 6x, what would we write as our answer? Negative 4x. Think about that process there. What we did was we added or subtracted the coefficients. Yeah? The 2 minus the 6 gave us the negative 4. Did we change that variable x at all? Did anything happen to it? No, it stayed the exact same. So you add or subtract the coefficients and you leave the radicand the same. And those are our rules for adding and subtracting. Any questions on that so far? Okay, so let's take a look at letter A. I'm going to highlight every time that my radicand is the same. So in letter A, are the radicands the exact same? Yes, they're both 3x. I'm going to highlight them. That means I can add the coefficients together. I have a 3 minus 8, which gets me, what the heck is going on? Negative 5, right? Why won't this erase? What the heck? Oh, okay. So 3 minus 8 is negative 5, and then the radicand is going to stay the exact same. That's it. Take a look at B. Are the radicands the exact same? Yes, so let's add them together. What's the number that's in front of that first radicand? It's like a negative 1, so let's put a negative 1 in there. Negative 1 minus 5 is negative 6, and that radicand is not changing. It's still radical 6. Fantastic. In letter C, are all 3 of those radicands the same? Yes, they all are 2y, which means we can add all of these pieces together. I have an 8 plus, this is a 1 here, minus 3. 8 plus 1 is 9. 9 minus 3 is 6. And then I have that radical 2y. Oops. That's going to stay there. Any questions on that? Okay, so then what happens when my radicals are unlike? So in letter A, for this next section, we have to take a look. Obviously, they're not the same. The first thing we need to do is simplify all the way. So I'm going to put a little note over here. Simplify fully. First. So let's break this down. Just like we did on our quiz. This is a good refresher from our quiz because some of us were making some silly mistakes. I'm going to take the 72 first. What breaks down into 72? What's the largest perfect square there? 36 and 2. So let's do, this is 36 times 2 inside the square root. Remember, I don't know what some of us were doing. We were making silly mistakes. That 36 is the perfect square. I square root it and bring it to the outside. So that should be a 6 on the outside. That goes away. There's just a 2 left on the inside. Yes? We're going to do the same thing for this other term. So I have a negative. 288 breaks down into 144 is my perfect square. I square root it before I bring it out to the front. The square root of 144 is 12. That goes away. All that's left in there is a 2. Now, in the two things that I have now simplified, do I have radicands that are the same? So I'm going to continue simplifying these two numbers. 6 radical 2 minus 12 radical 2 is -6 radical 2. Any questions on that? Okay. Is there anything the same in letter B as it stands right now? Any radicands that are the same? No. So we're going to simplify each one of these pieces separately. 2 square root 12. What does that simplify into? Cody? What does it break down? Or was your hand up? Oh, what does 12 break into, though? Thank you. 4 square root is 2. We already have a 2 out there. They're going to multiply together. That's a 4 when they multiply together. Leave the 3 in there. Okay, I've got a plus 6 radical 48. What can I break that down into? 16 and 3. 16 is the perfect square. I square root it. It becomes a 4. But there's already a 6 out there. So that's 24. That goes away. I'm left with a 3. And then what about this 200? What's that break into? Perfect square. 102. Lovely. 100 is my perfect square. I can square root it. It becomes 10. It goes to the outside. And I got a 2. Okay. So now everything's fully simplified. Are there things that can be combined now? What two things can get combined? The 24 and the 4 both have a radical 3. So these two numbers become what? 28, 4 plus 24, radical 3. Stays the same. Can that -10 radical 2 do anything? So I'm just going to rewrite it. And these two things next to each other are my final answer. This is 28 radical 3 minus 10 radical 2. Any questions on that? Okay, one more. Take a look at letter C. Are they currently the same? No. So I can't do anything with them yet. So I'm going to take a look at 15. Is 15 all the way simplified? Are there any perfect squares that go into 15? No. So I'm going to rewrite 15. Square root of 15. That's as simplified as it goes. Okay, look at 17. Are there any perfect squares that go into 17? No. So that is also all the way simplified. When something is already simplified, I do not want your answer to be none or nothing or not simplified or whatever you guys are putting on your quiz. Your answer, guess what, is this. In fact, this is your answer, right? Yes? Okay, I don't know why we were seeing things like the square root of 39 and we were writing like IDK. What sense does that make? This is your answer. If that is simplified, it's simplified, okay? Does that make sense? Hopefully we got that now. Okay, turn to your blue sheet.